Good morning, welcome everybody. I hope you're having a great time and you didn't have to try too hard to get here at 9 o'clock in the morning. I'm very pleased to see all of you. So I'm Dave. Those are my coordinates if you needed to contact me or anything. I work for Pivotal and I'm on the Spring engineering team. So I had I work on various different things. I had a part to play, shall we say, in some of the features that I'm going to talk about today. I didn't implement all of it, but I did do some of it. So some of the other people who've been involved have been Artem and Gary. Those are the two other Twitter handles I put up there. So those are the kind of core committers for Spring integration. I should probably mention Patrick Peralta as well. Patrick left actually, but he did a lot of this work before he left. And I suppose I should also explain the program change, right? So when I proposed this session, it was locks and leaders with Spring Cloud Cluster. So if that's what you came to hear about, then you're in the right place, but actually all of those features moved into Spring integration. So there is actually still a Spring Cloud Cluster project, but it's basically deprecated. I haven't actually officially published a deprecated version of it yet, but all of the features are now in Spring integration. So whatever I'm talking about today, just grab the latest Spring Boot, Spring integration 4.3.1, and it's all in there. Okay, so I've only got half an hour. It's quite a challenge. I realized after I'd proposed this session and when I started working on it that was woefully inadequate and I'm not really going to be able to do it very much justice. So what I hope that you get from this is some appreciation of the tools that we provide in Spring. Okay, so there are some features. I can show you them. And the second thing I think is important is that you maybe have some tools that you can use to think about distributed locks, leaders, the problems that you need to use those to solve and the problems that you don't. So the tools are probably the most interesting thing and the most important thing that you'll be able to take away, I hope. But watch out, right? There's a big warning on all of this. We can make it easier to consume the technology that provides these kinds of services, but we can't make you think, and you do have to think about what you're doing. It's dangerous, all right? Okay, so here's a sequence diagram, a simple distributed operation. It's distributed because I've got 3 swim lanes, a client, a storage service, and a webhook, and they're in different processes. Okay, so that's what makes it distributed. So let's say the client goes to the storage service and says, read me some data. And then it says, right, I'm going to write something back saying, I'm starting, I'm doing something. All right, and what I'm going to do is ping a webhook. So I go off and do that. And then I send to the storage service, success, I did it, it's fine. And the storage service says, okay, I understand. Okay, so that's kind of a simple use case that it happens to involve a couple of reads, a write, and an HTTP call. So then what happens if you have 2 clients? Okay, so there are 2 clients trying to do the same thing at the same time. They could be in different processes. It doesn't really matter as long as they're concurrent and independent. So let's say on a sunny day, the first client does his read, ping, success. Second client does read, ping, success. But wait a minute. It doesn't have to happen that way. It can happen in a different order, okay? You see what I'm doing? Because it's distributed, nothing says it has to happen in the order that I want it to. Okay? That's really the problem that we're trying to address, or the tool that you need to think about it. That is scary. It should be scary. You have to take that into account every time you do this, all right? So if you relied on any particular order, that sunny day? You better think again. So that's what locks are for, right? What we want to try and do is somehow reduce the surface area of the problem that we've got to shuffle, the calls that we've got to shuffle. So we want to be able to isolate the problem space so that we don't have to do too many of these permutations to analyze the behavior of our system, because otherwise it's exponential, right? You just can't keep track of all of the different scenarios and whether they're going to be successful or not. So within a JVM, you've got, native features like synchronized blocks, and Java util concurrent has this thing called a lock, all right? So if you've got one of these locks, you can say try a lock, wait 10 seconds. If you get it, that's fine. Then I've acquired the lock and I can do something. And when I'm doing that, I'm the only person who's got the lock within the JVM. That's the guarantee. And then to use it properly, I've got to catch an interrupted exception and pass it on. And I've also got to finally make sure I unlock the lock if I had locked it. Okay, so that's just a really useful API, within a JVM. So what we have in Spring integration is a little abstraction called lock registry. And what that's saying to you is, if you have an instance of this registry, then you can use it to obtain an instance of Java util concurrent lock. Okay, and the cool thing about that is that with this lock, it's going to do something a bit more complicated than just the local JVM Java util concurrent, right? It has the same interface, but what we're trying to do is provide you a sort of comfortable way to consume a distributed lock. Okay, so using a lock registry, the lock that I acquire from that, I can use it in exactly the same way. That's kind of the premise, all right? That's the hope, at least, with lock registry. If you're suspicious about that, then you should be, because it's a classic distributed systems fallacy, right? Things do not behave the same when they're distributed as they do when they're local. Okay, it might be the same API, but you shouldn't necessarily expect the same behavior. Watch out. It's nice that we can provide this, but don't let it fool you into thinking that you've got a local lock. So the lock that you've got in that case has to be managed remotely. And that has a couple of consequences. One of them is that a distributed lock nearly always expires. It would just be stupid to implement it any other way. Okay? So technically that makes it a lease rather than a lock. I can have it for a period of time, but I can't have it forever. And the reason you have to do that is because it's a distributed system. If the lock holder was to just disappear off the face of the planet, which happens, every day, network partition, crashes, out of memory, garbage collection, there's all sorts of reasons why that would happen. If you want the system to be able to make progress at all, when the holder dies, you have to expire the lock. And that's really kind of, the good news and the bad news, or it's the bad news and the bad news. That's life. And that's the way that things are. So there are dragons. Okay, there are going to be issues you have to worry about. At least two that I can think of. I mean, they sort of have large implications. I think having thought about this and played with this presentation for a while, I think I need to treat the world to another blog or something. We need a more detailed discussion of some of these things, but for the sake of the 30 minutes that we've got here today, the first problem is going to be to acquire a distributed lock. Whatever system is providing it needs to have a consensus, right? It has to, you have to be, unless it's a single a single node of something, if it's distributed itself, then it has to have consensus built into it. And consensus is hard, okay? Everybody knows that there are algorithms that implement these kinds of things, but nobody actually should be implementing it themselves, I would say. And the other problem is to do with the expiry, right? The leases expire, and if you're the holder of a lease, you actually don't always know when what you're about to do is protected or not, right? Because whatever you do, physics, right? There can be a delay between the time that you took the lock and whatever you want to do, assuming that you hold the lock. You can never make those two things atomic. It doesn't work. There are some tricks you can play. Maybe we'll get into that if we get more time later, or if I write this blog. So there are some special cases that you can exploit, but there's no general case. So I would recommend that you read this thing. It's a recent-ish blog, but he's been thinking about this for a long time, Martin Kleppmann. How to do distributed locking. And one of the concepts that he introduces there is the contrast between correctness and efficiency. So if you're using locks because you want to make your processing more efficient, you don't want to have two people doing something when one is enough, that's fine, and you don't have to think about it too hard. Pretty much anything you grab and use will be fine. In other words, it doesn't matter if two people do it. It's just more efficient if it's only one. If you're using a lock for correctness, in Peter's word terms, what that means is you must have only one. You're in for a rough ride. Very rough. I don't even think there is a solution. I think you can do your best, all right? But here's my public service announcement on this. You can tune things, you can be careful, you can adjust probabilities, you can make bad things less likely to happen, you can make bad things last for a short period of time, but fundamentally, you cannot prevent two lock holders from believing that they hold the same lock at the same time. It's impossible. Okay, so with that out of the way, let's have a look at some slightly higher level features. Leaders was the other thing in the title. So leader elections, the simple idea: if you hold a lock, then you are the leader. Basically, that's kind of what it boils down to. I mean, there are some APIs in different places that hide the idea of what the lock is, but basically, fundamentally, they're implemented this way. And if you have a cohort of instances of some service, and you elect one of them the leader, that means that only one of them is, for instance, processing incoming messages. So people use this idea to provide highly available things, right? So you want there to be only one processor of a stream of messages, and you want, if that dies, for somebody else to take their place as quickly as possible. So it's highly available and unique. So people need that if you need to do if you need to preserve order, for instance, or do message aggregation. Or the sort of poster child, which is actually some sample apps that I wrote for this presentation, and the one that I was kind of thinking of with the sequence diagrams. If you had a cron service, okay, somebody wants to ping a webhook once every hour and only once, you could use a leader election to do that. So in Spring integration, it's not even an interface, it's kind of a pattern called leader initiator, and there are some implementations. There's one for zookeeper, one for hazelcast. There sort of is one for etcd, but that's actually in Spring Cloud Cluster. It's not in Spring integration. That one didn't get moved over. The reason it didn't get moved over is because etcd is now gone. and released version 3, and so that's incompatible with the code that was in the client that we had, so we didn't move it. If anybody wants to resurrect it, they can, but to me it's probably dead unless somebody comes up with an etcd v3 Java client that just works. I mean, I'm happy to integrate that if anybody finds one, but so far there isn't one. I don't think it would be hard to do. I just don't think it's all that interesting at the minute for us. So there's a zookeeper implementation, a hazelcast one, which lives in, a zookeeper one is in Spring integration, the main release, so the 4.3.1 which just came out. The hazelcast one is in a Spring integration extensions project, so it has a separate release cycle, but it's the same basic pattern. And there's also a generic leader initiator, which is just using that idea that I had on the previous slide. If you have a lock, then you basically have an automatic way of electing a leader, because the leader is just the holder of the locks, Ali. The question is there any plan to support console? Not from me, but I guess it wouldn't be a stretch, because console already supports consensus, and you could do it quite easily. Yeah, it's very easy actually. I mean, the hard stuff is handled by console, and then you have to worry about your own problems. But the basic technology is actually pretty easy to integrate. Anyway, for a user, it looks like this. There's a thing called the leader initiator, and you just create a bean for it. Oops. When you create it, you can give it a sort of platform-specific or implementation-specific thing. In this case, it's a curator framework, so it's the zookeeper implementation. And this thing, which is a Spring integration interface, candidate. It's optional, actually, the candidate, because what the candidate does is it just gets callbacks. So when an application context is granted leadership, it gets this callback, and when the leadership is revoked, it gets this one. And so the reason it's optional is because there's a default implementation which just emits Spring application events. So you can just listen for those, and you get the same callback on the same thread. So that's the basic building block. It's very simple, actually, and therefore, probably quite a nice thing to be able to play with. So I've got a few minutes left. I'll make some closing remarks, and then I'll show you some of the sample code that I wrote. It's not a great room for doing question and answer, so I'll probably just invite you to come and ask me questions afterwards if you like. So a few more sort of background details about when people use these things. It's basically what I said. It's when you need something highly available but unique. You need one processor of a stream of data. Typically, is what it works. The way it works. So if you think about it, you could avoid that problem entirely by not needing to be highly available. If you only need to be mostly available, then you don't have to deal with all these problems. You don't have to think about it too hard, right? If there is only one instance of your service, and if that service dies, somebody will automatically recreate it for you, right? You can do that with Supervisor, daemons, with platforms, Cloud Foundry, you name it. So if you can suffer a little bit of latency just from restarting an app that died, don't even go there, right? Just don't bother with locks. You don't need it. You can just use a single instance and use a platform to keep it alive. Otherwise, really what it comes down to is the old problem of duplicate messages. Everybody knows that you can't avoid duplicate messages, and that's the same thing here. So what you need to do is, in your business operations, what you're doing effectively, if you're holding a lock, it's like receiving a message. you want to be the only person who's received it, but you can't be 100% certain that you will be. You can be, 99 plus 100 minus epsilon % sure that you're the only person. Nobody's going to tell you what the epsilon is, so you've got to have a gut feel for that. The only way to avoid it, the problems of duplicate messages, is to make your business logic idempotent. Same thing goes for distributed locks. And then if you start thinking about idempotency, what it really boils down to is, have I seen this message before, anywhere? And so you're in the business of deduplication. And the only way you can do that reliably is to go to a data store, which is shared amongst anybody who might have seen that message, and ask the data store, has anybody seen this before? And that data store, if you follow through the logic, basically it has to be consistent, for one thing. So in the CAP sense, it has to be a consistent data store, because there's no point asking it if somebody's seen this message when somebody else might be asking somewhere else and get a different answer. So it has to be consistent. And basically, if you follow through the whole set of scenarios, this line of argument basically leads you to ACID, roughly speaking. Doesn't have to be ACID, because like I said, there are some tricks. And the tricks are basically relational databases and zookeeper. Okay, and the way that people make these things work successfully is they use the same data store to manage the lock as they do for their business data. It's just such an old pattern. It hardly seems like I have to repeat it, but that's what you do, basically. Spring Batch has been doing that, right, since 2005 or something, 2006. Zookeeper's newer than that, but effectively that's what the Peter, the article that I mentioned earlier talks about. It's creating a lock and then interacting with the Zookeeper store at the same time, basically in the same atomic. You can make it atomic because it's, as Zookeeper is a consistent store. So there are some issues with that, right? Because nobody probably wants to keep business data in Zookeeper. That would be kind of crazy. Relational databases is a bit more realistic. So relational databases actually are your friend, after all, for a lot of things. But whatever you do, watch out for the physics. Because that statement, the public service announcement I made, I still firmly believe it's true. Right, the speed of light is the speed of light. You can't actually send a message any faster than that. And so the time that it takes for a message to get from A to B is the time that you could have two locks, two holders of the same lock, roughly speaking. And that's the absolute theoretical minimum, right? But of course, you're never going to achieve that. So life is going to be hard. Sorry. Here's some links, and then I'll show you the code, all right? So the slides, if you want them, those will be on my website. They'll also be on the speaker deck and SpringOne site and stuff like that. SpringOne Platform 2016 has its own GitHub organization, and I put some code in there, which I'll show you briefly in a minute. Spring integration, if you need to know about that, has those lock registry and leader initiator abstractions. Spring Cloud Cluster still has some of that code duplicated, basically. It's going to be deprecated, but the etcd implementation only lives there. Okay, so I said I'd show you a little bit of code. What I did in the sample apps, and I guess I'll make a promise. At some point in the next few months, I'm not going to say when, I'll turn these apps and this presentation into a more detailed blog and maybe tutorial, give it a bit of a longer discussion. What what I did anyway was I implemented this cron service idea in 3 different ways. One of them is just using the lock registry, from Spring integration. Okay, so that's how you do it if you're interested. JDBC lock registry is one of the implementations. Actually, I didn't mention that, did I? So I was talking about different implementations of leader, but there is a JDBC lock registry, as well as the zookeeper and hazelcast ones. So I'm using a database, and I'm using that to generate locks. And so if I had 2 instances of this application, they're both going to try and grab a lock before they do the webhook. And one of them's going to get the lock, the other one isn't. That's the way it works. So you've always got competing consumers here. If there's a webhook scheduled, then 2 people are trying to get it, 3 people are trying to get it, and one of them is going to win. For every webhook, it behaves differently. The leader example is using it still has locks, but it uses, where's the leader initiator? There we go, leader initiator. It uses a leader initiator to nominate one of the running nodes as the leader, so it's not competing consumers for the hooks anymore. When a hook is due, there's only ever one node that's going to ping it. So it's a slightly different implementation. Less chatty, but I suppose puts more burden on one of the nodes. Okay, you're not sharing any load across any of the nodes in your system if you're using that. And the other one I did, I called it Optimist, because it doesn't have the lock abstraction from Spring integration. It just uses the relational database. Okay, so the hooks are stored in a relational database anyway. You might as well use optimistic locking in Hibernate. Okay, so my hook entity has a version, so I can use that to, when I update the JPA entity, the version gets incremented, and then Hibernate will buff if somebody already did it. I can leverage that, and I can also leverage transactions. So there's a transactional service in this that with an update method, okay, and that thing is basically only going to be executed by a single node in this cluster. By construction, that's just the way the relational databases behave. So there's three alternative implementations of the same features. I'll write some more detail about them later, but if you wanted to browse them, have a play yourself. I set them up there in the conference GitHub organization. That's my half an hour up, so thank you very much for coming.